Okay, class. So today, let's look up at the board, make sure we're paying attention. So let's look at our topic for today. We're going to be learning about series circuits and parallel circuits. Now don't freak out, I know we haven't talked about it yet. That's why we're going over it. Alright, let's look at our next thing. So our objective today is actually to be able to explain how energy moves through a circuit and tell the difference between a series circuit and a parallel circuit and explain why. Okay. Let's go over some vocabulary review before we continue. So electricity, this is energy that moves through a circuit and makes things work, like turning on a light bulb or running a fan. So that's the energy that moves through the wiring. A circuit is a path that electricity travels through. It must be a closed loop. That means there's no opening. If there's a break in the loop, it cannot work. Light bulb. So we have light bulbs in this room. This is a device that changes electricity energy into light energy. So this is what we're having now, electricity into light. We have a battery. This is the source for the energy that pushes through for the circuit. It's our energy source. The wire is the metal path that carries electricity from one part of the circuit to another. So that's just the wiring, the path that the electricity travels through. Let's go ahead and do the next part. All right, I have a little video that we're gonna watch over the series and a parallel. Hold on.
Ever wonder why one broken bulb turns off a whole string of lights, but others keep glowing? It all comes down to how a circuit is wired. Let's break down the difference between series and parallel circuits with simple visuals. A circuit is a complete path through which electricity flows, but you can check the I button for how electricity actually works. Now, with an easy
I'm
example.
gonna pause it just to save time. So next, but in the real life, I would play the whole thing. All right, let's look at this. So let's look at our definition just to have a clear idea after our video. So a series circuit has only one path through which all the electricity travels through. So it's only one single path that has a series of things that it can turn on. So an example could be a string of holiday lights. If one goes off, then they all turn off. If a battery is connected to a light with one wire, kind of like our example here. We have one battery and we have two lights, but let's say this first one burnt out. What would happen to the second one?
It wouldn't work.
It wouldn't work because there's only one path that it's connected to the battery. So if the first one burns out, so would the second one. Let's look at a parallel circuit. So this one's a little slightly different. So I would have a point at which the electric energy is divided between two or more paths. So you would have two paths. If, let's say, this one burns out, this one would still work because it has a point of contact on both sides of the battery for it to run through. So this is kind of similar to lights in the house. So let's say one light in your house turns off, not all the lights in your house turn off at the same time. It will still work. Like if one of these lights turned off, the rest of them would still work. Okay. Let's go ahead and go to the next one. Alright, so this is going to be the guided practice. So I need you to pay attention. So, let's see. So, this is what a series circuit would look like. If I were to build this, let's see if I can open it. Okay, so what we're going to use is this website. You are not going to actually do that. But we're going to have, what should I start with when I'm creating a circuit? I think I need to create my energy source. So without an energy source, there's no way to build a circuit. Then I need my wire, that's why we went through, is to one side of the battery. Now I need something that electricity is going to do. What is it going to turn on? What is it going to be the purpose? Now we know it's closed by the light of the circle being black. If it's red, that means it's open. We gotta close it. It needs a connection. And that connection is done by the wire. So now I still have 2 more reds that I can close the wire. Now I'm gonna double check. I see that my electricity is moving, my light is turned on. That's how I know it's a closed circuit. There's no ways for it to open because I see the electricity moving and my light has turned on. Now, I know this is a series circuit because there's only one path that my energy is moving through. So, let's look back at the presentation. So that's my guided practice. Now let's look at, alright, so with the partner, you will be completing the following challenge. So, I want you to go ahead and open up the application on your computer. For the first step, let's add a light bulb to the series circuit as a class. Alright, so what happened? What did you notice when we added the light bulb? Let me go back. So if I were to add, let's add it to, you had a moment with a partner to discuss, to look at it, and then I asked you, how did you do that? So how could I add another light bulb to this?
Putting it at the end of a wire.
Putting it in a wire.
That was awesome.
Are both of the lights lit?
Yes.
Yes. Is this a series circuit or a parallel circuit?
A series.
Series. We know that because there's only one path that it goes through. Alright? Alright, so now we're going to create a circuit using 2 light bulbs. You would discuss with a partner. This is what it would look like. So, let's say that you created with your partner and you talked at the group. This is a parallel circuit. How do you know that?
There's 2 paths for the energy.
Paths for the energy. So if I were to turn off this bulb, what would happen to this one?
It would stay on.
It would stay on. We know that because there's 2 different circuits. Okay, so that was the guided practice. Now for their challenge, I did a challenge for early people, was put a switch into, so add a switch to the parallel circuit. Can you make one light bulb stay on while the other one turns off? That would be like the person that finishes early. That would look like something like this. If I open this one would turn off because it's no longer closed, it's open. There's a break in the circuit. Alright, let me move on. Alright, here's the independent practice. So, for your independent practice, you're going to design your circuit, include a battery, a wire, and 2 light bulbs in each circuit. Label each part clearly. So you need to make sure you label your battery, your wire, your bulb, and your switch. Or not your switch, edit that out. And then you're going to show how the energy is traveling through the electricity by doing arrows or lines to show how the electricity flows. Which direction is it going in? And then you're going to compare and reflect. So answer these questions after you finish. How does the flow of energy flow? How does the flow of energy flow in a series circuit? Does it go in one direction or in multiple directions? That's right, it's in one direction because there's only one path. What about the flow of a parallel circuit?
2.
There's 2 or more because you can have multiple different ways. How do a series circuit and a parallel circuit differ?
One can stay on while the other's off.
For which one?
For parallel
For
circuits.
a parallel circuit. So be sure to use vocabulary we've learned today after your conversation. Series circuit, parallel circuit, a current, and a flow of energy. And then you're going to draw 2 different circuits, one series circuit and one parallel for an example. Right? And then the closing, I would have a student debrief as a class. I would have them do partner work. So you're good. So the first question would be, how did you notice about, or what did you notice about how electricity flowed through the series circuit compared to the parallel circuit? So they're doing a compare and contrast, you would talk to each other. Then I would call on a few student examples. Then I said, imagine you're helping design the lights for your classroom or home. Would you use a series circuit or a parallel circuit? Why? And then you would discuss with each other. Which one would you rather use, a series circuit or a parallel circuit?
Parallel circuit.
Why?
I don't want all my lights to go off.
All at once. Probably a smart choice.
Scared of the dark.
All right, and I'm going to end it there. Wow.